Hi, we're going to start chapter 6 today, and we're going to talk about functions and relations. So the first thing that we need to do is cover a little bit of vocabulary to make sure we all know what these words mean. The first word is input, and these are the independent values. Also known as your x. And that makes outputs the dependent values, also known as y. And then relation is just pairs your inputs with the outputs. So pairs inputs and, well, instead of and, I'm going to put with. Maybe if it will let me. With outputs. Okay? Awesome. So let's take a look at some examples here, or I guess I should say some key ideas. So ordered pairs can be used to show inputs and outputs. And like I said, your inputs are always listed first, like your x values. Your outputs are always listed second, like your y values. Again, a relation pairs your inputs with your outputs. A relation can be represented by an ordered pair or by a mapping diagram. So the mapping diagram is you have a column of inputs and a column of outputs, and then you write your inputs and your outputs, and then you put the arrow to where they go. And you're going to see that sometimes they may cross, maybe not. This one just happens to go straight across. So 0 goes to 1, so that would be 0, 1. 1 goes to 2, 1, 2, and 2 goes to 4, 2, 4. So in example 1, it says listing ordered pairs of a relation. List the ordered pairs shown in the mapping diagrams. So I always just start with my first input and see where the arrow goes and write that as my output. So 1, 3, 2, 6, 3, 9, and 4, 12. But now if you look over at B, we have 0 and there's an arrow and it goes down to 0. So 0, 0. Then I have 2 and one of the arrows goes to 1. So 2, 1. But then I also have another arrow that goes to -2. So that would be a separate ordered pair. It'd be 2, -2. And then we have 4 to -3. All right, so let's go ahead and list these ordered pairs. Number 1 is, look at your first one there, it's 0. And the arrow goes to 12, so 0, 12. Next one would be 2, 10, 4, 8, and the last one is 6, 6. Number 2, a little different. We only have 2 inputs, but we have 4 outputs. So each input is going to have 2 outputs. So I have 1 and -1, and I have 1 and -2. I have 2 and -3, and then 2 and -4. So just make sure if one input has 2 outputs, that's 2 separate ordered pairs. Okay, let's take a look at what a function is. A function is a relation that pairs each input with exactly one output. And instead of writing that, I think I'm going to type it for you so you can actually see it. So we'll go up to 22 here. So it's a special kind of relation. So a relation that pairs each input with exactly one output. Okay, so each input can only have one output. So let's look at example 2, determining whether relations are functions. So if I look here, I have -9, 1, -2, 5. 5 goes to 10. 12 also goes to 10. But you can see there's only one arrow coming from each input. So that would be a function. Now, two inputs could have the same output, but each input can only have one output. So if you look at letter B here, -2, 1 only has one output, -1 only has one output, but look at 0. There's two arrows going away from 0. So 0 has two outputs, so that would not be a function. Okay. Example 3, describing a mapping diagram. Consider the mapping diagram at the left. Determine whether the relation is a function. Well, there's only one arrow going across from each input to each output, so yes, it is a relation. Then it says describe the pattern of inputs and outputs in the mapping. And so to do that, you just kind of look down your mapping diagram. So it goes from 15 to 30, it increases by 15. 30 to 45, it increases by 15. 45 to 60, it increases by 15. Then you go 1 to 2, it increases by 1. 2 to 3, increases by 1. 3 to 4, increases by 1. So you can say as each input increases by 1, the output increases by 15. Okay, so now we're going to do a couple examples. So number 1, determine whether the relation is a function. If you want to go ahead and answer 3 and 4 now, stop the video and try it on your own. And then when you have your answers, turn the video back on. Okay, let's check your answers. Number 3 is not a function. Whoops, not a function. Because they each have two outputs. They only can have one and they both have two. Number 4 is a function because each one only has one output. Each input only has one output. So number 5 says describe the pattern of inputs and outputs in the mapping diagram. So if I look here, if I look from 6 to 3, that's going down by 3. 3 to 0 going down by 3, and 0 to -3, it's going down by 3. And then if I look at my input, 2 to 4, that's going up by 2. 4 to 6, up by 2. 6 to 8, up by 2. So I can put, and I'm going to again type this so you can actually read it. As each input increases by 2, the output decreases by 3. Okay, so that was our notes for 6.1. Good job, everybody.